Good morning, judges. It is a pleasure to be able to speak to you all today about reducing carbon emissions in housing construction through creating 3D printing and materials hubs. Roughly 40% of the global CO2 emissions are produced by the building industry, where 11 of the 40 comes from building materials and construction alone. The global middle class is expected to double from 2 billion to over 4 billion by 2030. So to achieve the goal of net zero carbon emissions by 2050, it is important to redesign a standard US residential home so that most of the building can be repurposed, and that landfill waste from the construction and destruction phases is minimized. American homes are built according to standardized practices, allowing cheap and efficient construction of reliable housing. The figure on the left showcases typical American home construction. According to a 2017 study by the National Association of Home Builders, the average cost of construction alone for a 2,800 square foot single family home was 56% of the total.
What can we improve to reduce overall energy consumption and carbon dioxide emissions? In 2017, the US generated 569 million tons of construction and destruction debris. So the first area of interest was the refurbishment and recycling aspect. As you can see in this figure on the left, concrete involves the highest energy consumption, and on the right, over 70% of C&D waste comes from concrete and wood. So these materials were a priority to address. We propose using 3D printers to control the shapes and sizes of new materials, such as light stone material and bamboo OSB to replace concrete and plywood. 3D printed materials are known to be 4 times lighter than similar concrete structures, water and fire resistant, energy efficient, and more durable. Also, because they were created using 3D printers, they can be designed so that we can easily assemble and disassemble the materials just like Lego pieces.
Transportation and reuse of building materials are other key areas for improvement. Petroleum is a large percentage of energy costs for many materials, including lumber, gypsum, and concrete, the largest components of housing waste. Currently, raw materials are processed in plants and shipped long distances before being used. After disassembly, some materials are recycled, but most are either incinerated or buried in a landfill. To reduce these costs, we propose the creation of centralized depots for storage and sale of reusable materials for maintenance and building of new homes. The combination of our new 3D printed structures and these depots would encourage the growth of the reusable materials market. This system minimizes waste and allows materials to have many lives as they cycle through the system. The depots would maintain an inventory of both traditional components such as trusses, beams, framing material, and insulation, as well as include components made of novel 3D printed materials. These hubs would serve as 3D printer farms so that new reusable materials can be printed to suit the needs of their communities. Once these materials are no longer needed for one structure, they can be sold back to the depot for use in another structure. Similar markets currently exist for secondhand finish work, such as floorings, windows, doors, and tiling. The rest of the home should be reused in the same manner. Building depots in many communities would minimize transportation costs. This design addresses waste and transportation issues without changing the comfortable design of modern homes.
The average consumer will find the customizability of the homes appealing because we have not fundamentally altered the aesthetic of the traditional stick-built home that they are accustomed to. However, there are several changes in policy that can incentivize the deconstruction of homes. The EPA recommends the creation and enforcement of local laws mandating minimal waste. For example, these ordinances could require that deconstruction be planned in advance to obtain permits to build in the given locality. Currently, there are tax incentives in place that allow homeowners to claim the value of the materials removed in home deconstruction if they are donated to a charity organization. Although this is a great way to get individual homebuyers to invest in deconstruction, it is necessary to make it worthwhile for businesses. Additionally, high upfront costs may price out middle-class homebuyers. The higher cost is largely in the extra labor necessary for deconstruction, so a government labor subsidy would make the process more affordable. Public opinion on reusing materials also needs to improve to make this solution feasible. Societal focus on recycling has superseded reducing and reusing, both of which have higher environmental value than recycling. Building a strong brand based on the reduction of new materials through the reuse of materials that already exist in the community could lay the groundwork for this shift in public opinion.
Our plan will lower the cost of deconstruction by providing materials that are easy to assemble and disassemble. The central market would provide motivation for the homeowner or contractor to pay more upfront for deconstruction because they can then sell the usable materials at the marketplace. Those materials can then be resold, keeping them local. This system leads to high local efficiency, reducing labor costs, and improving sustainability. We'd like to thank MIT for hosting this hackathon and Gobain for providing a challenge for us to solve. Any questions?
Hey, thanks for the presentation, guys. I'm curious what kind of hurdles you guys might face trying to enact your marketplace. Like, what do you think the biggest challenges will be?
Well, some of the biggest we've thought of were the actual physical spaces being built. Of course, this plan is reliant on novel 3D printing technology. There's been a lot of big advances in 3D printing in the recent years. We expect that this will continue in the upcoming decades. So buildings like these could be a new commonplace part of like civil infrastructure, a place for materials to be deposited and withdrawn so that materials can be used within the same community many, many times. But as the biggest problems, addressing those problems with 3D printing, we believe will come as the technology progresses.
Thank you. Anton, Kim, questions?
Sorry, Will, my internet connection has been pretty shoddy. I heard you ask a question about 3D printing, but I wasn't able to follow the whole conversation.
No problem. Anton, do you want to ask a question?
Sure. Yeah, I can ask some questions. So in terms of like modifications to a building, do you foresee like the technology that you're implementing to help like expansion or contraction of a building, anything like that? Or is it mostly, when you build it and then when you destruct it?
Do you mean expansion and contraction as in like the actual expansion and contraction of the building according to like different temperatures or like times of year, or do you mean
like if you wanted to like add on to your building or make it smaller?
The hope was to be able to 3D print these designs in such a way that modifications could easily be attained. So if you wanted to decrease the size, that wouldn't be like impossible, but expansion would be more likely.
Okay, thanks. That makes sense.
Yeah.
Yeah, one of the biggest aspects of our design was the idea that these marketplaces would be available for people to come and go to suit their needs. So if there's a new housing development being built, people would be able to immediately go to these depots to get all the resources they need to complete these tasks. But if there were small general contractors that were building additions or maybe like a shed or some kind of smaller structure on a home, they could also go to these depots to complete their projects easily as well.
Thank you. That makes sense as well. Thanks.
I'm curious if you guys had more time, what do you think you would have done differently? What do you think you would have liked to expand on? What else would you like to have dug into?
I would say definitely, or Jared?
Okay, I would say for me personally, I would have liked to include sort of like a model mock-up in maybe Google SketchUp or a physical design of what we actually envisioned it would look like. More time for budgetary analysis, being able to, project capital and future costs, as well as navigation around municipal laws such as, zoning laws or like community interaction.
Apologies, Zoom is not letting me unpause or unmute easily. Thank you. No, that makes sense. And I appreciate you guys answering our questions. Thank you very much.
Yeah.
Thank you.
Thank you.
Thank you.
Thank you.